So there are several ways to approach this first problem, but I think the most simplistic for me is to just do piles. Since it's even, I know 2 divides. 2, 4, 8, 16. So I'm looking for piles of 3. I circle my pile of 3. That goes on the outside. Find a pencil that works. And what's left stays on the inside. No need for plus or minus because it's the cube root. Let's go to this one. This is going to be 10 to the 1, 2, 3, 4, 5, 6 squared, then to the 1/5. 6 times 2 is 12, and then 12 times 1/5 is 12 fifths, excuse me. And that's all I can simplify it. I'm not going to write the 5th root of a 10 or 1 with 12 zeros. That's ridiculous. Changing strictly to exponential form. This means 8 cubed to the 1/7. There's nothing else I can do there, so I'm done with that one. Okay. These other ones I'm going to probably go a little bit more slowly. When I look at this one, this is the cube root of 5 over the cube root of 128. When I look at 128, it's even like the 16. So I'm going to go over here and do the cube root of 2, 4, 8, 16, 32, 64, 128. You can tree it and get the same thing. So I'm going for groups of 3. I have 1 group of 3 and 2 groups of 3. So 2 times 2 makes 4. And I'm left with one of the 2's, cube root. And then I have the cube root of 5. Cube root. The numerator is fine, the 4 is fine, but this isn't fine. I need to have a group of 3. So I've got to give this 2 more. And if I'm going to give it to the bottom, I have to give it to the top, and 2 times 2 is 4. This gives me another group. So there's a 2 with the 4, which means an 8 in the denominator. Move that up. And then 5 times 4 is 20. They're not exponents, so you're not adding them. They're just numbers. And there's my answer, no plus or minus. Okay. When I see this problem, 243 is the same thing as 3 to the 5th. To the 2/5 is 3 squared, and 3 squared is 9. Then x to the 15th to the 2/5, 3 times 2 is equal x to the 6th. So my answer is 9x to the 6th, odd root, no plus or minus. Remember, when I'm multiplying exponents, I really add. So negative 2 minus 2 plus 1 is negative 3. 6 to the negative 3 means I move it to the denominator. Oops, I skipped a step, sorry. 1 over 6 cubed, and 6 cubed is 216. 1 over 216. There isn't a plus or minus. I'm literally simplifying it all. I'm not taking a root of anything. That's really when you only have to deal with the plus or minus. So like if this was an even root, then it might be plus or minus. But you're not even rooting anything here. Okay. I see a negative 4. Bring it down. I look at the a's now. Negative 2 and 1. Negative 2 plus 1 is negative 1. And then I have 1/5. Take away 2/5. Or subtract, whatever. And that's negative 1/5. So that's what I have so far. Now, if it's a negative exponent, not a negative number, I move it down. But the problem is that I can't have a fractional exponent. I'm sorry, a fraction in the denominator. So the negative 4 stays where it is. The a stays where it is. And I have to figure out how I can still have 1/5 more on the bottom. Remember, think of money. This is like 20 cents more on the bottom because 1/5 of a dollar is 20 cents. So if I have $1 down here, that's what b to the first is, then I have 80 cents here, which is 4/5. I still have 20 cents more. Okay. Show me at least 4 ways to write this. Well, I'll write it exactly what it says, the 4th root of 16. 2 to the 4th to the 1/4. That's another way. Oops, to the 4th. It's also negative 2 to the 4th to the 1/4. That's another way. I could write it as the fourth root of 2 to the fourth. I could write it as the fourth root of negative 2 to the fourth. Another way is I could rewrite that as 2 squared, which is like 2 to the fourth, to the 1/4. I can give you the answer, which is plus or minus 2. I think you get the idea. So that's the front half of the review. Let's go to the back half. The back half is all solving. So, since that is square root, the way to get rid of that is to square it. That cancels. This cancels, but there's still the 5. So I have to square the 5 because it's outside the radical. And then I'm left with 2x, which I'm going to multiply. I multiply that together. 3x minus 6 equals 50x. Small x to big X. Negative 6 equals 47x divided by 47. X equals negative 6 over 47. Okay? Let's go to the next one. It's to the 1/3 power, so if I cube it, those 3's canceled. And I'm left with 7 minus x equals 4 cubed. 4 times 4 times 4, 64. Subtract 7, just solve for x now. Divide by negative 1, x equals negative 57. Okay. Now the next one is very similar, but you can't take things to the 4th power until you make it isolated. So we still have that 4 on the outside. We still have that 2 on the outside, just like you're solving for x. Now that it's just x to the 1/4, now I can take it to the 4th power. And then x equals 1296. Now I would like to point out, if this problem said 2x to the 1/4 equals 6, that's when you would take it to the 4th power. And then you'd be left with 2x equals 1296. Then you would divide by 2. And then you get x equals 6, 4, 8. So notice the difference. This whole thing is taken to the 1/4. That's why you take it to the 4th power. For this one, the only thing taken to the 1/4 power is the x. All right, let's go to the next one. Starts the same way. Plus 1, 3x to the 2/3 equals 729. I'm thinking when I see a 3, it feels 3 to me, so I'm going to rewrite this as 3x to the 2/3 equals 3 to the 6th. Okay. And I'm going to deal with getting rid of the 2 first because I feel like it. So I'm going to take that to the 1/2 because then that'll cancel. I like making that answer smaller. It seems too big. So I'm left with 3 cubed equals, gone, 3x to the 1/3. Now you didn't have to do it my way. You could have taken it the cube, or taken cube to both sides and then taken to the 1/2. It doesn't matter. And then when I take it cubed, you will end up with 3x equals 3 to the 9th. That's something you should end up with. Whether you dealt with the 1/2 first or the cubed first, doesn't matter. Now when I divide by 3, that almost seems ridiculous. But if you think about it, there is literally 1 3 there. So if I had 9 and then I had 1 on the bottom, my answer is 3 to the 8th power, which is a really big number. Okay? All right. I think this was changed to 5/2, so let me make sure it's consistent. This was my old answer key. All right. First thing I do is divide by negative 2. Now, if I'm dividing by a negative, I'm really multiplying by its reciprocal. So if I'm dividing by negative 2, I'm really multiplying by 1/2. So I'm going to go straight to that. That's gone. The negative's gone. So it's x to the negative 5/2 equals 1 over 32. Now I know that 1 over 32 is the same thing as 1 over 2 to the 5th. And I don't like that this is a fraction and this isn't. So I'm going to make this negative so they match up. So it's really x to the negative 5/2 equals 2 to the negative 5th. Now I'm going to multiply by negative 1/5. Now that's canceled. I'm left with 2 on this side. And if you see, I have the 2 still on the bottom, so it's x to the 1/2. How do I get rid of x to the 1/2? I square it. So 2 squared is 4. Last one, cube it, because it's cube root. So I'm with x cubed equals, say cancel, x, set it equal to 0, factor out the x, square root, set it equal to 0, and actually all of them end up working because the cube root of -1 is -1, the cube root of 1 is 1, and the cube root of 0 is 0.